Hello class, today's your final exam for Physics 1. I hope you're ready. Good luck. Ben? Sal? Well, I said at the beginning of the semester, half of you aren't going to be here after the first exam, so...
5 hours later.
Gus, why are you so late? The exam was 4 hours ago.
So sorry, I keep walking my fish. I have to take a test.
I guess. Take a seat. Here's your exam.
Try my best.
Thanks, Gus. See you next week.
Yes, sir.
Alright, class, I've graded the final exams, and pretty disappointed, Only one of you got the question right. Like what? So, Ben will be explaining the problem tomorrow in class. See you then.
Okay, so we have statics problem C, where we need to find exactly what value of B and theta would satisfy this scenario. So as a statics problem, we have to recognize that the sum of all vectors in each dimension are 0. So let's say the sum of x vectors are 0 and the sum of y vectors are 0. These are statements we know to be true. And this is what we're going to prove when we solve for B and theta. So starting with the x dimension, we can say we have a force coming in from here, which we're going to say is positive because it's going right. And in the y dimension, we'll say going up is positive. So for x, we have 8 kilonewtons going this way. We have 5 times the sine of 45 degrees going this way. And we also have negative magnitude b of some angle theta cosine. Okay? And this equals 0. And so effectively, we can rewrite this using algebra, and we're going to say that b is equal to 8 plus 5 of sine of 45 degrees over cosine theta, where we don't know what theta is yet. We're going to have to do a system of equations using the dimensions in the y to figure that out. And so we'll do y. We have 12 minus 5 cosine 45 minus b sine of theta unknown. And we know this equals 0. So we can substitute b for what we solved here. But first, let's approximate these solutions. So if we solve this out, we evaluate what this quantity would be, which is approximately equal to 11.53, right? And so b, therefore, is going to be 11.53. I'm sorry, I did the wrong one. We approximate a 8 plus 5 sine 45. So we approximate b for 11.53 over cosine of a theta unknown. Okay, and then we can plug that into here, and we have this is equal to approximately 8.46 minus 11.53 cosine theta unknown times sine of a theta unknown, and that equals 0. So let's rewrite this as 8.46 minus 11.53 times tangent theta equals 0. Rewrite. So 8.46 is equal to 11.53 tangent of theta. We'll isolate tangent of theta such that it's equal to 8.46 over 11.53. And then we're going to take the inverse tangent of this. So we have arctan of 8.46 over 11.53. That's going to approximate theta. So now that we have theta, we have solved for this part. But we still don't actually know what b is. So given that b equals approximately 11.53 over cosine of theta, we can solve, and we will get b is approximately equal to 36.3 degrees. Now we can use this to find what b is, such that b is equal to 11.53 over cosine theta, where theta is equal to 36.3 degrees. And that will give us approximately 14.3 kilonewtons. thus finding the other part of this question. What would the magnitude of this force be such that it's at an angle theta that would make this whole system balanced? Okay, now that we have solved for our values of b and theta, we need to validate them. We need to see if they hold true with our original conditions such that the sum of all vectors in one dimension are equal to 0. So, for x, it should be true that 8 plus 5 times the sine of 45 degrees minus b, such that it's equal to 14.3 times cosine of 36.3 degrees should equal 0. And in fact, what we get is an approximate answer of 0.0108, which is off from the correct answer by only 1/100th of a kilonewton. And then for the y dimension, we have 12 minus 5 times the cosine of 45 degrees minus 14.3 times the sine of theta, such that theta equals 36.3 degrees. And once again, we should get that equals 0, and we get an approximate answer of 0.001. It is off by 1/1000th of a kilonewton. So I'd say that these approximate values for theta such that it's equal to 36.3 degrees, and b equals 14.3 kilonewtons, are very, very close to their actual values, and so they would be good substitutes. The importance of statics really can't be overstated. It has applications in nearly all facets of engineering. It doesn't matter if it's mechanical or industrial or chemical. There are points in which you're going to need to evaluate any part of the system such that it is in equilibrium. And there's a lot of things you can determine by understanding what that means. When you know that a system is balanced, the things you can determine and the functions that you can create for unknowns such as this, there's a lot of, you can figure out anything, basically.